In this unit, we're going to talk about set theory and its logic. It is two different outcomes, and we'll start off with the understanding of set theory, which we'll talk a little bit about Venn diagrams. Venn diagrams and such. And then we're going to talk about some inductive deductive reasoning, talk about conjectures and such. Or, sorry, not converse, inverse, contrapositives. Well, it's still in everything like that. Here's your overall rubric. Now let's get started. So there are different types of sets and set notation. This is just a kind of nice Venn diagram, just has a nice little introduction. You can take a good read at it. The biggest problem with a 4-point is that there's no real connection between this bank robbers and preachers. Obviously, in this case, there shouldn't really be anything that are just directly related between bank robbers and preachers. Same thing as there shouldn't be anything really related between DJs and moms taking off your sweater. But you can see that there's no overlap between just the DJs and mom, or just bank robbers and preachers, but there are specific overlaps between DJs and bank robbers, everyone on the floor, or preachers and mom, as God as my witness. Whereas if we look at this one right here, I know you're better than this, that means it's the overlap between DJs, mom, and preachers. So let's talk a little bit about terminology. First bit is, what is a set? So a set is just a collection of distinguishable objects, just a collection. An element is just an object that's in a set. And a universal set is the set of all elements that are under consideration. So we're going to talk about all of that kind of stuff in this set notation. This U being the universal set. So the universal set will be defined by X's, which are all the elements. Such that X is less than 10, where X is an element of the natural numbers. So this is the set that's under consideration. So all of our X's that are less than 10, but natural numbers, each X that would be that, like 1, 2, 3, 9, are all elements. And the universal set is just talking about everything that we are considering. Now we're going to get into a little bit of more notation and such like that. Subset. A subset is just a smaller part of a larger group. It's notated with a kind of a sideways U. It's kind of more like a C, but it's not the problem. There's no word element that looks like it. It's actually just that sideways U that you can see it down as union and this intersection, but it's just a sideways, basically a sideways U. It's just saying that if we're considering this set, the numbers 1, 2, and 3 are a subset of the X's that are less than 10, but an element of the natural numbers. A union is notated with AU. It's all the elements in one and or both sets. So it could be in one set, or it could be in both sets. Just talking about everything. That's probably the but it's everything that's in a set. An intersection, notated with an upside down U, it kind of looks like an N. The easiest way that I can always remember is union looks like a U, and intersection, the N looks like an kind of N. It's all elements that are strictly in both sets. So we'll talk about what that really means in our examples, but it has to be in both. A complement is notated with an apostrophe. As all elements, so all parts, all objects that do not belong in some kind of subset. And then disjoint sets are sets that don't have anything in common. They don't contain any similar elements. So we're going to tie in all of these things with this first four terminology in some of our examples. So our first example, we're going to indicate the multiples of 4 and 12 from 1 to 240 inclusive using some set notation and list any subsets. So what that means, and then we're going to represent it in a Venn diagram. So if we want to talk about all multiples of 4, well, how would we say multiples of 4? First, using set notation, we'd say all the x's such that multiples of 4 are always defined by 4. 4 times, let's say, n, such that, n being an element of the natural numbers. So all of our multiple four are just going to be x's. Whereas if we want to talk about multiples of 12, we'll call them y's. Multiples of 12 will be 12 times n, where n is an element of the natural numbers. Now keep in mind, again, natural numbers are like 1, 2, 3, 4, 5, 6. So 12 times 1 is 12, 12 times 2 is 24, which also leads into talk about what this subset is. Multiples of 4 is directly part of all multiples of 12. Every single multiple of 4, or sorry, every single multiple of, sorry, other way around. All multiples of 12. That works a lot better. All multiples of 12 are actually a part of the multiple of 4. Because multiples of 4 talk about 4, 8, 12, 16, 20, 24. Well, 24 isn't here. So what we can say is that y is a subset of x. We've defined that y's are your multiples of 12 and your x's are your multiples of 4. So y is a subset of x. Your multiples of 12 are a smaller part of your multiples of 4. Now, if we want to represent this using a Venn diagram, don't go down too far. Yeah, I'm just going to make 2 nice big circles. And we're going to list multiples of 4 and multiples of 12. So let's see. We'll call this one x and this one y. So we have 4, 8. Oh, y, the number 12 is a multiple of 4. But it's also, or a multiple of 12, but it's also a multiple of 4. So we would have to call that here. 16, 20, 24 is a multiple of 4, but it's also a multiple of 12. What we will further see is that no matter how far we go, all of our multiples of 12, all the way to 240, are part of our multiples of x. So the better way of actually representing this is actually like this. So this would not be the best way. So then we'll talk about one other thing. This entire circle means all of our multiples of 4. That circle there will be the multiples of 12. And this would be your 4, your 8, your 16, 20, 28, 20, 32. And this would be your 12, 24, 36, 48. So this would be all of the 4n. And this would be 12n. But we're not fully finished there because we have to talk about all the multiples of 4 into 4, 120, from 1 to 240 inclusive. Well, there are numbers that are not actually part of these multiples of 4, multiples of 12. And that's what is known as the entire universal set. The universal set being every single thing under consideration. So we want to just indicate the multiples of 4 and 12. But from the numbers from 1 to 240, we have numbers that are not part of here, like 1, 2, 3, 5, 6, 7, and so on and so forth. So the universal set is every single number, from 1 less than or equal to n less than or equal to 240. And being natural numbers. But within that universal set, we have our multiples of 4 and our multiples of 12. So this is the idea behind having that universal set. All right. Now I just want to get with some terminology here. So if by chance I roll two four-sided die, yeah, there are some, but it's just a little bit weird to deal with. Let's talk about 2 4-sided die. Okay, one die could be 1, 2, 3, and 4. 1, 2, 3, and 4. That would be the second die. So we want to see what the question is asking for the sums. So 1 plus 1 is 2. 1 plus 2 is 3. So on and so forth. Uh, 7, 8. That would be all of the sums possible. So first thing we're going to do is we're going to display the following sets in a Venn diagram. So these are just all what the sums are. Let's do a Venn diagram for this. So we have a nice big box, which is going to represent every single sum. We'll call that the universal set. Now we have rows that, and now we're going to have two sets. We're going to have rows that produce a sum less than 5. Let's call that, we'll use x as y again. Set x are all the rows that produce a sum less than 5. So everything that would be less than 5 here. And y would be all sums that are greater than 5. So there's x. Now, you'll notice that I'm drawing it this way because of what the situation is. Rows that produce a sum less than 5. Well, we're going to have a sum of 2. There's 2 different 3's in there. And there's 3 different 4's in there. A sum greater than 5 will be like the 3 6's, the 2 7's, or the 8. Oh, okay, sorry. I forgot to notate them in the right way, sorry. But we'll call less than 5 L's and we'll call greater than G's. If you just want to change these to X's and Y's, that's fine too. I'm just going to go with what our notes are having. So I'm just going to erase X, erase Y, and call this one G, and this one L. So the question is, this is some notation. So N represents number. That little N right there, let's talk about the number. So the question is literally asking, how many are in less than 5? How many are in this circle? Well, you quickly count. That's 6. Number in G. Okay, that's 6. Number in L complement. Okay, let's go back to that first page, just see what that means. Complement, notated with that apostrophe. It's all elements that do not belong to a subset. So in this question, this says, how many are not in L? Okay, so we can quickly count up and say 6, right? No, that is actually wrong. Because you might have noticed that when I made this table, there are all these things. There are 4 5s that are not lower than 5 and not greater than 5. So there are 4 parts that are not in L and they're not in G. Meaning there are 10 things that are not lower than 5. And then last one, NU, number in the entire universal set. 16. All right, you can have some fun.